Okay. Uh, this is we're going to be dealing with POPs chapter 603. But before I forget, let me turn this off. Yesterday, if you go back at the very end, we were discussing on chapter 602 an error, a warning pertaining the object type of a series, and that I had turned off the warnings. Well, I did figure it out. Let's recreate the warning first. Bang. I've removed from up there the warning suppression uh, directive code. So we should get the warning. There it is. Remember, it's a deprecation warning. The default D type for an empty series will be object in the future instead of float 64. So specify a D type explicitly to silence this warning. So this D type here, which is the type of the values in this series, it's going to be changing soon, and they want you to warn you that you need to state it explicitly. So if we come here to the code, you see where we use the series, we can add, it's as simple as this, Peach. You add that, the D type equal object, I like it like this, and it gets rid of the warning now, because now you're explicitly saying that the return type for that series is type object, like the instructions want you to do for future versions. And now the error should not appear, and it doesn't. And the format changes slightly. Instead of a decimal, float, we're getting just the count of the frequencies of these things in the key column. All right, so that's that yesterday. Today, we're going to see mostly, in the first couple of examples, it's really simple stuff. They apparently want you to be familiar with something called PrettyTable. So we import pandas as usual. We've imported numpy for one little thingy down there. We've imported sys for output to show you what standard out is, which is this. This is the standard out here, the console. And we're going to be using PrettyTable across the board. Now, because I have one file where I have a number of examples, I'm going to have to be naming the objects for PrettyTable, appending the A, B, or C of the example, because otherwise it all gets into one big file. So I'm going to run this thing to get the examples there on the console. In example A, we're going to be using ex5.csv, which is a simple, and this is the line that we're going to be concerned about now. It simply prints to the console, which is the standard out. There's another standard out, which is standard error, which would have not printed anything. It would have gone to another place. When you want to hide stuff that goes to the output, when you don't want it to go to the output, you can make it an explicitly to the standard ERR, and it would not come out. All right. So this one here is a data frame to comma separated value going to the standard out with the separator equals the or that bar there. Okay, the one thing here is to remember that if you have a if you have a missing value, for example, here, this did this doesn't the way to print this is not doing it like we had before, so it doesn't give you the functionality of putting a not a number in there. You see we have this bar here. That's because there's nothing there in the data file. And I believe that after, and also notice, and this is true for the other lessons, when you have a not a number value or bad value in a column, the the numbers in that column become decimals. Check that out by yourself. But like for example, if we're using pandas, which is not the case down here, you'll see that if you have a column with an error, instead of integers, the numbers in that column become decimals. For example, between the 6 and the 8 here in EX5, there's a no value there. So in that column, which would have been the green one below number 4, below the 3, see the 3, which is in that column, is displayed as 3.0. And then in that same column, the 11, which are the greenish color here, that 11 is also displayed as a decimal because in that column we had that problem. It may be a little bit of a help, I guess, that Pandas is trying to give you. If you look at a column and you see that instead of integers you see a decimal, then look further in that column because there has to be something wrong in that column. Alrighty then. We're gonna comment that line and uncomment the next one. In the next one, we have printing to the standard out and replace the not numbers with the string NULL. Run it. And now up here you see that in the places where we had problem data, the word null has replaced those values. But still, if you notice, numbers in the rows that have problems are shown in decimals rather than in integers like the rest of them in that particular file. I'm going to again comment this guy out and uncomment the next one and run it. Here, what do we have here? Oh, the file does have an index. I mean, Pandas puts an index normally, and the file does have a header, which are those 01 through 06. In this case, we're saying turn off the index and turn off the header. So therefore, we have only the data here without the application of the pandas 012 indexes and without the header, which are up here. Alright, easy stuff. Mm-hmm. 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 In this example, we have no index and the columns are going to be supplanted by these guys. Now here, I noticed that you have to use the same numbers, but not the same quantity of columns, but the same numbers and not even the same order, but you have to use the same column headers that you had here. I need to use 01, 02, 03, but I can skip some and I can in this case, I can put them out of order, which is what I've done here. The indexes in the file are consecutively 01 through 06, but here I've put 6 of them, I believe. But see, the second one is 06 and the last one is 02, but all of them are represented. Let's see what happens there. So here you see that index 1 is still in its position, but we have the sixth column on the second place here and the second column on the last place. Let's look at the second column in the last place. 159. The second column, 159, is actually, yes, in our last place, 159. And of course, the sixth column, which is NA, World, and Foo, has become our second one here. Yes, to World, Foo. Alrighty then. Now, the other thing you can do with this argument is that you can say, okay, I only want to see columns 1 and 2. La 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 la, or whatever, whichever combination you want there, really. It's pretty cool because you can you can study selected columns in that way. There you go. Only those 2 columns, columns 1 and column 2. We'll put back the rest there. Boom. Oops. Little details. Okay. That's that for example A. Example B. In example B, we're going to start using the PrettyTable thingy. It's just a thingy that helps you format. Has a few nice functions. It's just an alternative way. Here, I'm naming the object here in the constructor for PrettyTable PrettyB because it corresponds to example B. And in other cases, we have PrettyC, for example, C and so forth, because in the beginning I didn't have like that, and it would combine the thingies here. It would combine the files. So using the object, you can tell, okay, I want my field names to be such. Now the file has to have that number of rows, which it does. Now we have a loop here with the file as f of example b, file of example b. Read the lines, you've seen this in Java. And while there are lines at rows, this R strips the spaces from the end, from the tail of the string, and it tokenizes by the commas that separate the tokens, the words, whatever. And so it reads the lines until there are no more lines, and then I'm printing it using the object called PrettyB, which is of type PrettyTable. So let's see example B. It does this little thingy, and there are many, many ways of prettifying the delimiters here for the table. You can also find arguments where it would justify your numbers to the right or in the middle and so forth. Create a line after all of those good thingies that you can do. Oh, you can also output a file that would open nicely in Word, for example, and so on, I believe. Here, though, we're not using pandas at all here. We're just using PrettyTable. There's no pandas in this example. And so you see that the data element that was missing over there in the file, it's empty here. It's still using NA here, and so forth. So you have to remember that this is not a data frame. This is just plain old vanilla comma separated value. Let's look then at example C. In example C, we're using PrettyTable again. The six headers are now A, B, C, D, E, and F. What happens is that I created another file called ex5b to fix the missing elements of ex5, like this 7 was missing here. I think I fixed the NA there. Yeah. 1, 2, 3, 4. Okay, that was an extra element or something there. So now we have 6. The colors agree with the columns. We have a good file that doesn't have problems. So it's called that. We're going to read it, go through it in the same way, but this time we don't have problems. So there you go. There you go. That's the difference there. Very simple stuff. Example D. In example D, we also use a PrettyTable. Oh, example D is the heavy one. Okay. It's a time frame thingy. It's a time manipulation, date manipulation thingy. So we're going to be using PrettyTable for the final output there, but first we are going to see what a pandas date range looks like. You will start with a date in that format. You can say I want 12 of them, 12 of years. Frequency is going to say, okay, I want them to be 12 years. And I believe that's what we have on the right. So date time index is the format for the plain vanilla date. That's the type of data. It seems to be a tuple. And the frequency is, I think it's annual, decimal. And what we can do here is we can change that to, so you see the years are changing here, 2021, 2022, and it's given us the 31st day of that of December. So it's given us the last day of that year. December 31st for every year from 2021 through 2032, 12 years. We can change that to month, 12 months. And there we have them. 2021 for every year. The last day of the month from January through December. February has 28 days, so it's good. All right. And we can also do date and others. We can do seconds and so forth. But let's finish it with days. All right. So what do we have now? We have 12 days from January 1st of 2021 Day 1, day 2, day 12, up to day 12. Right on, sister. Now, if you were to print, okay, now here we've printed the raw datetime the object that the date range function returns. But if you want to format it, then you can use time series, again a series which we saw yesterday. You need to use NumPy for this. It says, okay, arrange 12 objects and use the date time index, that whole thing, put it here as an argument in the series. Powerful stuff. So now we have a pandas series with the date time index that we previously created there as an argument called index, and we're going to print it, and this is what we get because we had it by days. So there we have the 12 nicely printed. All right, lastly we have uh, a loop that's gonna go through a file that was created let me see, I think I created that file. Oh, here it is. This time series that we had, we used it here to create a CSV file called time series.csv under examples, which is this. So, and the last time that we ran it, it was by day. So there we go. I don't know why, but it always creates those two headers empty there, an empty and a zero. No matter how I try to get them out, there must be a way to get rid of that or something. I don't know. At any rate, this actually creates a file from the series that we have just created, and then it also prints it here by going through the lines, stripping the rightmost spaces, splitting it in tokens when it sees comma, and using the PrettyTable functionality to put the thingies around it. All right, that's it for today, Kuna. If you want the code and more on date, I think it's important in general to understand how the date and the times are used. I have links for that. If you want them, let me know. I also have documentation on the PrettyTable. It does some other cool stuff, like I said, and so forth. So, mija, I love you. Have a good one.